That's words, yes. Famous, famous, famous. And it's showing up here. This is exactly the correct title, so let's freaking go. So today well, this is a recording, right? So we need to also make explicit that we did the string library. It is here on the right, and on the left, sorry, and it works. It took a little bit of time, and it also took finding a bug in Objective-C's runtime, which was not fun,
Uh,
but we did it.
Lemos, Lemos,
Yeah.
I cannot see what you're seeing. You
Oh
are not
yeah,
sharing the
that's
screen.
true. There. So the string library now works, and now we can finally focus on the game, right? And the game rules are pretty straightforward. So we walk, and that's actually the idea that I had about making a function that walks through a three width window actually. So you pass the 3 bits as the values for the function, and it outputs to you. It put backs on the stack the new middle guy. So I thought about doing that, and the game's was pretty simple. So you just basically check your left, check your right, and these are the next states basically, and that's it. So
And
what do you want to start with, Marinho? And I also noticed that we need something like one, and we need the ASCII for it, so probably 60 whatever. Also need a zero, which I also don't remember, of course. So ASCII table. Marinho, are you there?
I am.
So the number.
Sorry, wait a second. Yes, by the way, 1 in ASCII is actually the number 49, and 0 is 48.
Okay, so 48, 49. And why we
That's
need this? Because we're
backwards.
gonna. That's
That's
backwards,
backwards.
yes. We need this because we will be writing them, right? Many, many times. And this is where the constants live, apparently. So where do you want to start with, Marina? Let's actually explain a little bit of the entry point of this thing. So we also discovered, well, it was not that big of a discovery, but we found a way to actually have new lines as the escape character, which is to basically put the ask version of it, and the write syscall will interpret it as escape sequenced new line character. And the value of the new line is actually 10, which I think also should go here. So I call this new line with a dash. Let's call this the new line without a dash.
You can actually call both of them the same thing because what determines which name we are looking at is the prefix character.
That's true. So let's put this here, and this actually should just work. So let's actually run it to see it working. Um, so I'm gonna make this a little bit bigger. So this is gonna be result chime.
Uh,
So we have samples rule, and we're gonna have
by the way,
key there.
shout out to Rekka Tower because it's because of that project that I know, like, just memorized what the ASCII code for a new line is.
That is indeed true. We had a problem with that, and Marinho will never forget. I always forget, so I'm fine. Okay, so where do you want to start with? So what is happening here is basically setting the new line. Okay, so this is a function to set the new line, and the main function is basically doing that, and basically printing the universe, and then printing a new line, and that's what we're gonna be doing. multiple times actually. I think we actually should do something like print universe. Okay. So let's assume
Okay.
that you pass the universe that you want to print as an argument for it. So you already have that on the stack. Um,
Isn't that just call right?
uh, I was thinking about doing the set new line thing here every time because that's not a problem to me. This is already on the stack. Then we do
That seems
a call
that seems a
again,
bit wasteful, but okay.
and then we do a write, and then we do a call again, do a ret, and then do a print new line. That's it. So then now we can print the universe.
You have a call and a return that could be changed into a jump.
Yes.
I
There we
will
go.
never not mention that, by the way, because tail calls for the win.
Yeah. I know what you mean. So this now, instead of doing all of this thing, we can just do that, boom, uh, and then print universe, and it works.
And it works.
Okay, so let's start. What do you want to do?
What do I want to do?
Oh, hello, nice flake. Uh, yeah. So hello. So there's someone in the chat. Yeah, this is actually doing it. So this is using Nix, just for to show that. Uh, and you may not know this, but this is Objective C, and it works with Nix. So there are some things that don't work with Nix, such as Common Lisp, but this one does, surprisingly. So there's that. Go on, Mari.
I think we can. How do we start? Um, First of all, I have an idea for what to do for the ends of the string, right? Of the universe, because it's represented as a string, it has a beginning and an end, and we need to decide, okay, what's to the left of character at position 0, and what's to the right of the final character. I propose that we treat it as a circular string, actually, and what's on the left of the first character of character at position 0 is just the final character, and
Mm-hmm.
what's to the right of the final character is the first character.
Yeah, but is that easier than just jumping them? Like I was genuinely thinking like starting from 1 and going to 126.
Uh,
But if it's easier to go all around, like wrapping and stuff, that's fine. You see, it worked. The Nix thing worked. Poggers
I
for that.
mean, the string is 128 characters, right?
Yeah.
Uh, oh, actually, what that means is that um, we can probably get away with just doing some masking to fix that, because normally you would have to do a modulo to do this cyclical behavior.
Yeah, for sure.
But because 128 is a power of 2, we can just do a bit mask instead.
Okay. So if that's easier, let's go with that. So, how do we start? What do you want to do first? What's your strategy? I was thinking about doing the window thing.
Uh, yes, that works for the inner loop where we actually do the work of computing the next state. Um,
Mm-hmm.
and then around that, I was thinking. stack the two universes, right?
Mm-hmm.
And then we'll have a function that, given the current universe and a buffer pre-allocated for the next universe, it computes the next. So that's where the loop that you were thinking of will go. Uh, and then we print the new state, and then we just swap the two buffers, the two string pointers, and then we'll probably want to have a counter, right, of the number of iterations that we
Oh
want
yeah, yeah, yeah,
to
yeah, yeah. I
execute.
forgot about that. I forgot about that. This is gonna live here.
And then we just go back to the beginning and do a loop
Yeah.
with the two strings basically just swapped in the
So
stack.
I'm kind of feeling that we should go from like bottom up instead of doing like the outer loop first. I'm kind of feeling that it's gonna be easier doing the smaller pieces first.
Okay,
So what do you think about that?
okay, that works, I guess.
Okay, so this
Yeah,
is
and
kind of
it,
the
it
interface I was
probably
thinking.
yeah, and it probably is easier. So
So this is kind of the interface that I was thinking of. What do you think?
give middle, um,
Actually, this is kind
left,
of
middle,
misleading. This is
right.
actually like next.
Mm, that would be an okay approach if we had traditional registers, but we don't.
No, 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 but we have find character. It's fine. It should be fine.
The problem is that we'll have to juggle 5 values on the stack at a time if you go this route.
5 values.
Yes, because we will have the two string pointers, right? The previous one, which is where the values that we are reading come from, and the next one, which is where we're going to write the result.
But we can just throw the pointers that we don't need in the R register.
Well, yes, but then that still doesn't change the fact that we have to care about where they are.
No, we have to care. I agree. I agree. About that, I agree.
Um,
So what is your thought process? If this is not a good interface, what should we do in its place?
uh, I was thinking of a function that takes the two strings, the current universe, which we are looking at, the next universe that we are producing, and an index. And it says, okay, for this index, what should be the value in the next universe given the current universe?
That sounds more like a top-down approach, but you're saying so this is gonna be like previous U, current U, and index.
Yes.
Okay. And this is going to return the next universe. How that's going to work? Or this is going to return
And
the
that's
next
actually,
value.
no, this will actually mutate the current universe.
Okay,
Because
so
remember,
actually we need
that's
to
what
define
we're
we need to define actually that. Do you prefer having universe and next or previous and universe?
universe and next or previous and universe. I prefer previous and next, actually.
That's confusing. That's really confusing.
And oh, wait. You mean for the names of the
Yeah.
labels?
Yeah.
Actually, I prefer universe A and universe B. Because we are actually not going to hard code the two universes as like in the middle of the code. Because since we have to deal with the two universes anyways, I was thinking of making them parameters actually.
Okay, so we're gonna say that this is UA and UB. Is that fine?
Okay.
Okay. Um, so let's think about that. So you, in order to
And by the way, universe A and universe B are also references. So
what?
universe
Oh,
A and universe
oh,
B are references.
that was an accident. I promise. So I think because we
No, no, no,
need.
no, no. They are. That was very much intentional on my part.
Ah, okay. It was completely an accident from my part. I think we need to do something like this. Actually, because we're gonna save one copy, we can dupe it again later. I think. Yeah. And why we need to do that, I can explain. Because we need to do a minus and a plus on it, right? As well.
A minus and a plus. Right, because we need the not only the current index that we are computing, but also the one on the left and on the right.
Actually, actually, what about doing that right now? Because we have minus 1. I guarantee you have minus 1. So we could do a call, uh, and then push R, then dupe again, plus push R. So then we're gonna do, and this is gonna be next value. So the call is gonna be to minus 1, then push R, dupe again, plus with a number uno, then we save that again. And effectively what we're gonna be doing is this.
Plus is an instruction. You need a literal before the plus.
No, that's true. Very true. Cool. So we already have one, two, we have 7 actually. So this should go here. Okay?
Yeah, actually, you may not want to pre-compute the two indices right now, because the thing is, you may not actually need both of them.
Okay. So in that case, we're gonna do just dupe pushar, save the index for later.
Yeah, save the index for later.
Next.
So what convention are we going to take? That the universe A is the one that we are looking at now, or the universe B is the one that we are looking at now?
What whatever is easier in terms of the stack manipulations. I don't have experience to judge that.
Okay. In that case, it's probably easier. It's probably easier if we say that the one on the bottom, so in this case, universe A, is the one that will write to. So it's the next iteration, and B is the current one.
Okay.
Because the first thing we have to do is actually grab values from B and look at their current values. And
Yeah.
because B is closer to the top of the stack, it's easier to access.
Sure. But
Okay, so
I
in
still
that,
think we're gonna need a function called give middle because we're gonna extract the 3 values from the universe B right now, and
actually, no, we won't.
oh, we won't. Okay, go then.
No, what we're gonna do is the following. First of all, do an over because we want to use the universe B and also save a copy for later.
Sure.
And then a swap. Do we need a swap actually?
Well, tell me first, what do you want to achieve? Then I can try to help.
Swap, and then we do have a function to grab the character at index, right?
Yeah.
So we're gonna call that after the swap.
No, no, no. But, ignore instructions. Tell me at the high level English language what is the goal here, please.
Okay, the goal here is we're going to look at the character at the character at the position that we were given. So
Mm-hmm.
we're going to check if it's a 0 or a 1,
Now let me see first what that
because that
changes.
actually uh,
Yeah, if it's a 0, okay, that changes basically nothing. Go on.
it does change, because if it's a 0, we just need to look at the next character, and if it's a 1, we change the current character to a 1.
No, 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 no. I mean, when I said it doesn't change much, I meant that we are checking for 0 because we can do something without checking the neighbors. But it seems to me that if it's a 1, we check a neighbor, and if it's a 0, you also check a neighbor.
No. If it's a 1, you have to check both neighbors.
Yeah, no, no.
But if it's a 0,
I didn't mean to
you
say
only have
exclusively one or the other. Sorry. I was thinking, is there a way, is there a case, a corner case, in which you know the value of the middle and you immediately know the next one without looking to anyone?
no.
Yeah, so that's what I meant. Go.
But there is a difference between a
No, there
0
is a
and a 1,
difference.
because
Yeah.
yeah, because if the current value at the position is 0, that means that we actually only need to look to one neighbor, the one on the right.
Yes.
Where if it's a 1, we have to look at both of them.
If it's someone, we have to look at both of them. Okay. So the first thing that you want to do is, oh, so the swap is to correct the stack for the calling the find character function. That's why you need it.
Yeah.
Uh,
Yes.
okay, so this is correct. So because we should have took notice, like written, what is the interface of these guys. But it's only two functions. We should not have that many problems. Come on.
We really need comments in this thing. But well,
We really need
either comments or documentation. Which may not be a bad idea, actually.
No, in a language without labels, comments are more than documentation. They are saviors because 1 month from now we're gonna forget. I guarantee you.
No. What I mean is, instead of having, since we don't have comments, we can just have another file called rule110 dot. Well, you use org mode, so you can use that if you want. And we have our comments in a separate file, actually, because the assembler that we are using doesn't have comments. You see?
You can make an issue on the repo to add comments. Okay.
Well,
So let's actually try to remember find character. I think the find character expects the index to be on the top because it's gonna do find word immediately.
yeah.
And as far as I remember, find word will also assume that. Where the heck is find word? Here. So divided by 2, so this is division by 4, adding +1 to jump the size of the string. So yeah, so I think this is in fact swap, call, and find character. And as far as I remember, this will return on top of the stack the character that we are asking for. So we
Yes.
did a swap. I think that consumes the index, so now we have a char here.
The UB will also be consumed, if I recall correctly.
The UB will be consumed. That's the type of stuff that I have absolutely no idea at all. Um,
Yeah, we need stack annotations.
we need. But I told you this before. This is part of my argument still. You have automatic function composition, cool, but the lack of labels, bro. The lack of labels. This is what
No, no,
happens.
no. We just need them like at the definition of the function, and then that's fine. What the problem here is that we can't actually write them because we don't have a syntax for comments, which is why I propose to have them on another file just for the time being.
Okay. Um. So let's see. So what is the API for find character? I think is the string p. So let's put here. So this is find character, and then we have the index, and the output of this is. That's the problem. We're gonna have to read. There's no a way around it.
Oh no, actually it's much easier if we say, okay, what's the API for find word first?
Okay, so find word. It takes an index and returns the word index. As far as I can tell.
Okay.
Yeah, definitely takes the word index. Then um, we save that. Then we do a call. No, no, no. We do a call for find word. That's okay. Then we do a plus. That basically means that we are basically addressing that word in the string itself. Then
Yeah.
we do a push load day. So this is the referencing. Pop R, the index again, the position that we are interested in. Find the
Yeah.
byte and find byte. Oops. Find byte. Wait, what find byte takes?
It
It
takes a
takes
number and
it
does a
takes an
bit mask,
index
essentially.
and it's a fixed index. I use that nomenclature. I remember that. Then we have fixed fix endineous, which basically picks a fixed index and returns more fixed index. Hilarious. And then we do a shift. And I think, if I recall correctly, the shift right expects dereferenced string plus uh, fixed index, I think. No, wait. Yeah, this is
Actually, I
only
think it
index.
expects
This is
the,
only index.
yeah,
And it also expects a more fixed index. And it
and
returns.
returns the character. It returns the character.
Okay, I'm gonna believe you. So this is the char. So that means that this is also that, right?
Could be, yeah.
Could be.
We expect it to be is more
Okay,
appropriate.
so then that means that the UV is gonna go away. Let's go on.
Yeah.
So what do we do now? Now we need to check if the value of the char is a 0 or to check if it's a 1. Actually, we don't need to do
I think,
both. We need only to do one function because if it's not a 0, it's definitely a 1.
yeah, I think
So check 0.
we, yes. So check zero would be, we don't have XOR, right?
Oh, actually, we don't need this. We don't need this. We need two functions, and then we use jump 0 here.
Actually, no. We just need. Oh yeah, we will use jump zero, but actually, uh,
Hmm? Does that sound reasonable?
1, 2, 3, 4, 5, 6. I guess. I mean, well, I guess it does.
Okay. Uh, so as far as I can tell, the jump zero consumes the char. Do you remember that?
It does. The problem is, okay, we do swap, we do a call to define character, and then jump zero. Oh, but the problem is that the zero character is not actually represented as a number zero.
What's the... Oh, the zero character is not that. I'm so freaking sad. Yeah, we do need check zero. Okay, okay. So let's assume that check zero is going to receive only a char. This is going to be a call. And the call is going to be to check zero. And what we're going to be doing is uh, uh, literal and jump zero.
That's not really what's gonna happen.
And then we put zero here,
Yes.
I think.
I think we may need a not actually.
Reason?
If you just say 0 and 0, and it is in fact 0, um, we will just get the same character back that we had two copies of.
Hmm? I'm confused.
Uh, because because that's a because that's a bitwise end, and the number that we have is not actually a 0. It's a 48 if I recall correctly.
No, it is a 48, but if the char is a 48 and we are putting a 48 and do an end, oh yeah, you're correct. This is a bitwise. That means that we're gonna get another 48, right?
Yeah.
But otherwise we're gonna get zero, right?
Well, no, we actually may have
Oh, we may have
something
something
else.
else. That's true. That's true.
Yeah.
No, but then wouldn't couldn't we just do? Wait, do we have equality? I don't remember.
We don't. We have to derive equality. I think there's an example of that in one of the other programs.
So what is the name? Do you remember the name? Oh, I don't want to do that.
Um, let's see.
So
Um,
samples equality. This is how you do equality.
oh, we
Okay.
have an XOR instruction.
Yeah, no, but I
Right.
prefer
We
this
can
actually. I prefer this. Because then we are leveraging our examples. It's even better. Somebody took the time and care to write this. And that's what we're doing. That's the only thing we are doing. We are leveraging it. Agree?
Okay, I
Okay, so
agree.
that means that we're gonna do that. Call, well, it's called in return, so I guess
Equal.
it's a jump. And this is gonna be equal. Hmm? Hmm? Come on. Not so. This is not so bad, right?
Right.
Okay. So then we check for 0. So that means that after we are done with it, so we call that, we're gonna check for 0. So on top of the stack, we're gonna have a 0 or a -1, correct?
Correct. That
That
is
means
correct.
that now we can, if and they are, it's gonna be 0 if they are equal or not equal actually.
It will be 0 if they are different, because 0 is false.
Okay, so it's gonna be then jump 0, jump, and this is not the place that you do that. And then we're gonna put. You said that if it's 0, they are different, right?
If they are different, it's 0. Yeah.
Okay, so this, right?
Right.
Okay. Um, okay, actually this is now vanished because this is now equality check. The jump 0 will consume
It's going
that.
to consume it no matter what. Yeah.
Yeah. And then no, but that's the thing. Before doing the second jump, we may need to do something about it. Actually, before the 2 jumps, we may have to do things about it because we have the index in the R register. Do we need to pop that back?
We do actually.
We do. Yeah.
It's generally not a good idea to have stuff in the R register while you are jumping.
I see.
Uh,
So then after that, we're gonna
or
have
does
this.
we have to do a pop now? Yeah. Yeah.
But
Pop
this is
R,
now we need
swap,
a
and
swap.
then swap, and then jump 0 and jump. Yeah.
Amazing. Awesome. Then, with that in mind, let's go first to which one is the easiest one? Is 0 or is 1? I think they're equally okay.
Well, is 0 is just look at the next character,
Okay, let's go with 0
and if
first then.
it's
This is gonna be consumed as far as I can tell, so gone.
yeah.
So now the E0.
So
So what we need to dupe again.
uh,
Index this. You said we need to check for the previous or the next one?
next one,
Next. So this is a literal, then a plus.
and the literal is 1. Um, actually, we should probably do a push R before you do the literal and the plus, because
Sure. I'm a little bit concerned about something, and I want you to pay attention to that.
okay.
Are we gonna? I don't think that's gonna happen, but we need to be careful about doing +1s on like 49s or something. We need to take care about that because I'm
But we're
100%
not
sure that
doing.
at some point I'm gonna do it. At some point I'm gonna write this.
Yeah, that would be bad.
It's gonna be terrible to find it. Okay, now we do what?
Um,
Find again?
yes, we do a find character, although we don't want to get rid of the UB, so we need to copy that as well.
So actually, push first, dupe,
No, we
then
don't
pop.
have to.
Yes. So now it's already there.
But now you don't have the index in the R register, do you?
Oh yeah,
Or
we're
rather,
gonna have
you
a.
got rid of the.
Yeah, no, we're gonna have 2 dupes.
Yeah, but we don't need to do any of that actually. We can just keep the code as it was and do the over after we have the index
No,
plus
but then
one.
we're gonna have to do a swap.
And that's still easier to follow than just push R, dupe, pop R, and then like
I don't know about that. So we duplicate the index, save in there, uh, add a literal, do a plus. Yeah, this is the current situation. So now we do an over and then a swap. So that will effectively put an UB here. Then
yeah.
we call, this is already 6, so
Um
call,
yeah,
find
call
character.
and character.
According to this, it will give us the char, that,
And then we have to check if this character is a 0 or a 1.
call again, check 0,
X 0. Um,
so let me check the table here. So we know that the middle guy is 0, and we know that the guy to its right, it's also a 0. What do we do about that? We output, do we care about the left guy at all?
no, we
No,
don't.
it's
Uh,
always 0. So in that case, in the case that it is 0, um, we go and say jump 0 on it, and then we're gonna have to make a label here. Actually, I want to check the instructions now, because the only thing that is the conditional to 0 is the jump. Yeah, unfortunate. So we want to have a label here called put 0, which is basically literal 0 on it. I imagine you're gonna have to do something very similar to put 1. Uh, so that, oops, put 0. And then the question is, if it's 1, that means that the check 0 said these guys, these guys are not this is not a 0 on the left. On the left, no, on the right. Then what we do?
this is not a 0. If it's not a 0, that means it's a 1. We propagate the 1.
We propagate. It doesn't matter at all, the other guy. It doesn't matter at all. So in that
It doesn't
case,
matter.
we do jump and put 1. And this should needs to do the returns.
That's backwards, by the way.
What?
X0 returns a boolean telling us if it's a 0 or not. If
Oh,
it's a
that's
0,
true.
the
That's true.
boolean will be
That's
true.
true. That's true. For my bad. My bad.
Um, right, but we have a slight problem here. First of all, we still have the index on top of the R, or on top of the return stack.
Yeah, but after the jumps, we're gonna have actually this is vanished because, and
Yes.
I can explain why. Because the when we do find character, it will consume the duplicated universe B and the index, and it will return us the char. And then we're gonna go check 0 on it, and this is gonna be equality check. And the jump 0 will consume it regardless, right?
Right,
And
but
then the jumps will
before we do
put
the jump
a 0
0,
and a 1.
yeah,
I'm gonna call
before
it
we do the
next.
jump 0, before we do the jump 0, ideally we should do the
Pop,
pop R and swap. Yeah,
swap. That's not
yeah,
what we
swap.
want. Oh no, we do want the swap, sorry. Because then the index was gonna go here. Perfect. So after all of that, uh, Now it's
We
right
don't have the
character.
next when we jump, by the way.
We do. We do.
No, we don't.
No, 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 no. After the jumps. This is the outcome after this line.
You really don't want to do that, actually.
Oh yeah? What do we want to do then?
Because if you do a jump 0, you're going to put a 1, and then you're going to return to the color of E0. That's not what we want.
Oh, so these are calls actually.
Oh, those are jumps. Those are tail calls,
Yeah,
actually.
those are tail calls. So that means that we're gonna have to. Yeah, but it's so inconvenient though, because the only thing that is conditional is the jump 0. This is very inconvenient because we should be doing calls here.
Yeah. Mm.
Okay, so I'm gonna propose
Maybe
to
instead of just put
write
0 and put
next,
1 returning,
right next on it.
yeah, they should. No, no, no. Instead of returning after put 0 and put 1, they jump to right next.
Yeah, no, that's my proposal. We had exactly the same
Yeah.
idea. And then they just go right next. So that means that this is
It
now
should be
here.
an ampersand there, by
Oh,
the way,
yeah, it
on put
should be an
1.
ampersand, yes. There.
And then we just mutate the universe A with whatever is at the we actually we have a slight problem there, actually, because we have to do some juggling to get at the universe A that's below everything.
That's not a problem, it's just a bunch of pushes, that's fine. Um, so it's gonna be push R over pop R, pop R, swap. So it's gonna do UA, oops, next index.
And you came up with that in seconds. How far have you come?
But
And then we can just
I
do
told you,
a and
I'm gonna get used to it.
and then we just do a I think we have a call or a jump to the function that mutates a string, right?
Yeah, yeah, yeah. We're gonna do call, and then we're gonna pass write character. And I'm pretty sure this is how it works. I think the character goes in the middle, but we can need to check that.
It goes. It does go
Uh,
in the middle.
yeah. So the index needs to be the first thing again. So let's assume it is that. I'm pretty confident it is.
Uh, I think we can just jump to right character and then we're done.
Okay. So jump, and then what
I'll
that's
be
gonna
right back.
do? What that's gonna do? Because I don't remember the outcome. I think actually the outcome is none because it's effectful only. But
It
I don't
consumes
remember
everything
what
and
gets rid
mutates
of. I don't
the.
remember what gets rid of the. What it removes from the stack.
I think it removes all the arguments and just mutates whatever
Okay,
you
so let's
pass as a
assume that.
pointer.
So after we're done with that, um,
But yeah, I'll be right back. A few
okay.
minutes. Just
Okay, actually that's not true. We need to do a call here and then a jump to main loop. Okay, so I'm assuming that these is gonna be pretty similar. These two guys, they're gonna be pretty similar. So if the middle guy is 1, uh, oh, it's actually a little bit more complicated than the E0 guy, which is unfortunate. Sure. Okay, so the first thing that we do actually is I don't record anymore. Ah, screw it. So I think it's gonna be something like this. Here we're gonna have the index, and here we're gonna have the index as well. Yeah.
All right, I'm back.
Okay, I
Did I
think
actually take 2 minutes, or did I overestimate my fastness?
I didn't count. I was thinking about these one. I also noticed that this
Okay.
cannot be a jump to right character because we need to call and then go back to the main loop, which doesn't exist yet.
Well, no. Well, no, because well, it depends. How do you want to do the main loop?
We're gonna no, the main loop is gonna be like checking the number of
Be-
generations. It's gonna check if the string ended or something like
no,
that. It's gonna
because
do
if
a bunch of
because if the
stuff.
main loop, no, no, yeah, but if the main loop it actually calls the function to write the characters.
No, no. What the function is
Uh,
gonna call is this one.
well, yes, it's gonna call that one, but eventually it's going to reach either is0 or is1, and then when we return from that, we go back to the main loop, right?
Yeah.
That
Oh,
means
I
that we
see, I
can
see,
actually
I
just
see. So then
jump
you,
to write
yeah, but
character because
that's kind of, you see what's happening here? You see? Uh,
yes, it's a tail
the
call.
tail calls, we are making the tail calls like context dependent because now you cannot just read a function and understand the like most of how things go. You need to know that we're gonna call at some point, and all of these guys are doing jumps. And when you eventually return, you're gonna actually return not to your caller, but to the one of the address of the return stack, which can be anybody. You see what's going on here?
But that's true in general
No, I
for
know
any
that's
call.
true. No, I understand that's true in general. I'm just saying that in a language this low, in something this low level, this is so much harder to track. Jeez. Okay, okay, but that's a lesson learned for me at least. Because if I was not doing this with you and we are doing this together, if I was just reading the code, I would have to pick a piece of paper and like take notes, which is sounds bad, but I guess this is like we cannot run from it because if you want the tail call at this level of a language, you need to do it. There's no way around it. You need to do it like this. But anyway,
Yes, you do.
so I was fixing is1, I copied is0, but as far as I can tell, is1 is a lot, it's a lot more annoying than the other guy because um, if it's one and the guy and its left neighbor is 0, it doesn't matter the right one. So I think that's the case that we should do it first. So this is going to be a call, and this is going to be 2 minus 1.
Actually, if it's one, you have to look at both neighbors, and
No,
they
no, no, no,
both
no.
have to be
No,
one.
you're going to have to look at both. But take a look. If the middle is 1 and the left is 0, it doesn't matter the right.
Oh, short circuiting. I see.
So we're gonna just not do it if it's -1. So do -1. So this is gonna be index -1 after the call. Then this plus we're gonna get rid of that. Then we do an over, then a swap. So this is basically putting UB here. Then we do a call on find character, and find character gives us the char. Then we do a find character, not, then we do a call to check for 0 again, which basically is going to change this to equality check. And if they are 0, they are, I forgot again. If they are 0, they are different, right?
Yes, correct.
Okay, so if um, okay, so we checked for a 0. If it is 0, that the left neighbor is 0, that means that we send a 1, and that's it. Um, so we are saying that they are different, but we know that the middle guy is 1. And if they are different, the left guy needs to be 0. Then we're going to put a 1. Yes, this is correct. If this is 0, we're going to put a 1. Because you already know that the middle guy is 1, and because they are different, that means that the left guy is 0. Nice. Now, if they are not 0, the quality check, that means that they are the same. If they are the same, then we need to check the right neighbor. All right. So we're gonna put is1 stage 2, and we're gonna put
Uh,
that here.
there's a trick that we can do here actually.
Go on.
If we know that the current character, the one in the middle, is 1, and the left character is also 1, then the output is just the opposite of what's on the right.
Wait. If the middle guy is 1 and the left guy is 1, it's just the opposite of the right one. Yes, that's correct.
Yes, because if you have a 1 surrounded by two ones, the one in the middle suffocates, so it becomes a 0.
Yeah.
Uh, but if it's not surrounded by two ones, we already know that the one on the left is 1, so the one on the right must be 0, and the output is 1, which is the opposite of 0. Just as,
Yeah.
just as
No.
in
No.
the
No.
previous case, it,
We definitely
yeah.
can do that. Um. Okay. So let's actually do that. So what we're gonna do? Can we leverage? Can we leverage? We can call E0 and then do a not or something. Not a not literally, right? Because that's not going to work at all. But we could do that. And I like it, actually. Yeah. So here's my suggestion. Yeah. So we do a is1 stage 2 for now. I don't have a better name for this. I apologize. We do a pop r on it to put the index back in. Then we call is0. Oops. So E0 will receive this. Uh, it will receive this. Okay?
Is the index not already on the stack from the pop R before the
It is,
jumps?
but E0 is assuming that it isn't.
No, it doesn't.
What do you mean? Of course it does. This is why this is here.
No, I'm talking about the data stack. Like in the is one, before we do the jumps, we do a pop R and a swap.
Oh, okay. Let me read this a little bit more closely then. So we do this, duplicate, do a -1. Okay, I'm gonna have to put this down. So this is an R, and then after the -1, we're gonna have this. The over then the
You know,
swap is gonna do this. Then we do a call
I'm
on find
half
character.
tempted. I'm
This.
half tempted to make my own dialect of this assembler. And in
What do you
my
mean?
dialect, pop I'm half tempted to make my own dialects of this assembly language, like the keywords file,
Oh, the dialect.
and to
You
make
mean this?
yes, and to make the push R be an open bracket and the pop R be a closed bracket.
Sure, you can. That's the beauty of it. You can do this. Um, actually, that's a good idea, man. Now that I think about it, that's very good because it's helping you visually with what you should think about. Anyway, so then we do that. Then we do the the check zero thing. So this is gonna be equality, and if it's zero, we go to put one. But then we're gonna do this. So before going to stage two, this is the scenario, I think. Wait, is this a scenario? I am confused again.
No,
So we
no,
have the
no. You have the
char.
equality.
Oh, then we do an index, then a char. Because you do the pop r and the swap. So you have this, then you do check zero. So equality. You are right. You are completely right. We can just call this. Um, we can just call that. Hmm. So now I wonder, is check zero? Yeah, check zero is checking for zero again. So we could theoretically do a call on check zero again here, because at the end of this process, E0 is gonna put uh, it's gonna put the opposite of what we want, right?
Yeah.
Okay. I don't know if that's true though, because I think I feel like that we are cheating. You know? Are we really cheating?
Hmm. Why would we be?
Because if it's because E0 assumes that the middle is zero. So if it's zero and the right is zero, it's gonna return zero. If it's zero and one, it's gonna return one. And then we just yeah, that works. Holy shit. Okay, so then we do check zero on it. Um, then oh, no, we can't do it like that. We can't do it like that because they will write it. Ah, so sad. So sad, man. You see the problem?
No, we can just write a helper that given a string and an index, it flips the value at that index.
What? No, but you see what's going to happen. If we call E0 just to have the character, that's not how this works. When you put a 1 or you put a 0, you are not like returning that value. You are already doing the side effect because the put 1 and the put 0 will call right character right next, and right next will do the stuff.
No, but we can just call is zero, and then if we have a helper that given the string and an index, it flips the value at that index, that does what we need.
Yeah, but you see that we are doing an operation of writing that is useless.
Mm, well, no, we aren't.
What?
It's an operation that it's not useless in the sense that okay, if we were to try to optimize for memory write, you are correct. We shouldn't do that, but we're not actually doing that, are we?
Yeah. No, oh no, we are not doing that. We are not doing the optimization. But the reason that I felt it bad to do it the way that you said it, and just something, we need to also do a dupe and a pushar to save the index because we need to know the index to reverse it again. Uh, Not reverse it again, to reverse it. Because you want to make a function, as far as I can tell, you want to you want to pay the cost of like doing a one extra writing per is one. Every single time you do an is one, you're gonna do two writes, right?
Yeah.
Sure. And then you want to make a function called reverse, which picks reverse char. That picks a UB, that picks a UB in an index and reverses it.
Yeah. Yeah.
That's
That's
also gonna.
essentially it.
That's actually a lie. We are also paying for a find because we don't know what is in there. Is it expensive enough now?
No, it's literally just indexing into an array.
Okay, so we're gonna do call find character. That means that we're gonna have the char here. Wait, is it gonna consume the thing, right? I think it's gonna consume the thing. Yeah. So we need to do a before doing
Over
this thing, we need to
and
do an
swap.
over and a swap. Yeah. So now we're gonna have this after the find character. Then we do a call again for check for 0, which is this. Um, and jump 0. So the char will return equality, the check 0, sorry. And if the equality is 0, that means that they are different. That means
We need another copy of the index, I think.
we need another copy of the index. No problem. We already have it. That's why I added the thing here. So pop, and then jump. There. So the index is here, actually. So now the over is wrong though, because yeah, we're gonna have this. So you want to dupe and push, or just
Yeah, dupe
push?
and push R.
No, but we don't. We just push. We don't need to use the index for now.
Actually, you can just do two overs instead of over swap.
Two overs instead of over swap.
Yeah,
Hmm.
you can use the data stack instead of the return stack.
Wait a moment though. I think I got lost in the with the stacks. So when we enter is one stage 2, what do we have exactly? We did a pop R and a swap. Um, yeah, I'm lost. I forgot. That's the
No, look,
problem.
we call find character, we find the character, we check if it's a 0. Then the pop R and the swap is just to recover the index that we had saved earlier
Yes.
and still
So
keep the equality check at the top so
so
that the jump
then we are
0
doing
can do its
UB
thing.
here because it's a pop. It's a no. It's swapped. So the UB now goes here. What?
No. And then in the one stage 2, what we have, we're going to only use
Oh, I see. I
Right.
did a dupe and an index because I knew we would have to use the index again because to reverse it. Then we call
Yes.
E0, which is going to consume these two things, right? I think. Will it consume these two things? I already forgot.
Uh, it won't, I think.
It
It will
won't.
consume the index only.
Okay, so it's going to do that after the after the wait. Oh, it's here actually. Okay. So when you do that, we're going to pop R, so the index is going to go back to here, all right? And then we do a jump
Yeah.
to reverse char. Then reverse char, we'll do, there's no push char because it was already, no, actually that's a lie. Uh, do we
Actually, we
need
shouldn't jump to to reverse char because that's going to force us into having an awkward interface for it.
an awkward interface for it? The interface is this.
No, 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 no. Reverse char ideally should take a string and the index, and only those two things.
No, but it is taken. This is just the bottom of the stack.
The problem is that the string that we want to mutate is the one at the bottom, not the one at the top. You see?
Ah, I see. So in that particular case, then, uh, so this is here.
Yeah, instead of doing the pop R, we should do a swap, and then we call reverse char, and then we swap again.
Uh, wait, you said to keep this
Yes,
here,
we do this.
swap on it. So
Yeah,
this is A and this is B.
yes. Then we do the pop R as we
Wait,
were.
wait, 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 wait. Doesn't that mean that UB is wrong? It is with the character that it should not be? Does that matter
No,
though?
because so far,
Oh, it doesn't matter
no, it
because in
doesn't
the main
matter.
loop we're going to be swapping the universes, so it doesn't matter.
No, it doesn't matter because we haven't actually swapped the universes yet.
No, but we
Oh.
will. In the main loop, we will. Uh,
Anyways, we swap
swap,
and then
pop.
we pop
Uh,
R, and then instead of jumping, we do a call to reverse char.
so call on it. And I'm assuming that's gonna maintain the A, and then we do a swap, and then a
And a
ret.
return. Yeah.
Okay. So then this is the situation here. So
Yeah, reverse char takes a string and an index, only one string. We don't care about what's below that.
yes.
Ideally, we shouldn't reach what's below that.
Okay. So in that particular case, you don't need this, then neither this, then this, right?
No, 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 no. First of all, erase the one of those universes in the comments above because
We're gonna forget
we
it.
want to
We
pretend.
will forget it.
Yeah, forget about it. Let's pretend it's not there, even though we know it is.
Yeah, that's the
Because for the
hard
purpose,
part. Even though it is, I don't think we're gonna remember that.
and that's why we should not have it in the comments. Because the intention here is
I'm
that
gonna put it
reverse
in
char
here.
takes two values and it doesn't touch the one below that. It doesn't touch anything below those two, you see?
Sure. Okay, so what do we do now? So we have push R over swap. I don't think we need any of this.
Yeah, no, we actually need two overs.
Over, you said. So this is gonna put
Yes.
UA index. Then we do a call, which I assume consumes this.
Yes.
Then we do check 0 on the char,
Yes.
which is correct, which is going to transform this to equality checking. Equality checking. If they are 0, that means that they are different. That means that what is in there right now, it is different. No, wait, but this is wrong.
Why?
This is 100% wrong. Because the wrong thing that we need to reverse is not in UA, it is in UB.
That's why we did a swap before calling the reverse char.
No, but that's still wrong. Because reverse char needs to find it. And the finding is not in UA.
But we already mutated the target string before.
You said that we mutated. No, we mutated the B.
Yes, and then we did a swap, and we're actually operating on the universe B at the moment.
What? That's not what is written in here. We did that over, and we had UA here. Because we did a swap, but we are reading from the UA. We should not do that. We should read from the UB, reverse and apply in UA. Hello? Are you there?
I'm thinking, give me a moment.
Sure.
Look, let's finish implementing reverse char first, and then we go back and double check if we are actually doing a swap where we shouldn't.
I think it's going to be more complicated than that question, because if I'm correct, we need the two universes here, right now.
No, we don't.
But that's what I think the conclusion would be. But as you said, let's finish the implementation of this. So if the jump 0 says that it is different than 0, and we need to swap it, then we put a 0. Right?
Yeah, if it's different than 0,
and we need to swap it,
yes.
We put a 0.
Otherwise, we put a 1, yes.
So yeah, but there's still junk. There's still junk in the thing.
That's fine.
Well, because the jump 0 is going to consume this. And what is the interface of put 1? Right next. Wait a moment.
Oh, right next.
Right next is assuming that it is always on the bottom. Right?
Yes, that's a problem.
No, that's not a problem. You just don't swap it. Done. No, actually you do swap, but now the meaning is that actually you need to remove the swap. Put it in here. And then you do your stuff. As far as I can tell. Jeez, okay, so this is hard. Okay, so let's backtrack a little bit because I think we got lost. Let me try to explain to you why I think your idea is not gonna work. So, do you agree that when we go to the is1 function, we're gonna have something like this? Do you agree on that?
Right. If the universe B is the one that has the current universe and universe A is the next one, then yes, that is correct.
Wait, what is correct? What I just asked or my conclusion?
No, what you just asked.
Okay.
Why would I confirm your conclusion when I disagree with it?
Because maybe you got it. That's the thing. But maybe I am the wrong one. So let's continue here. So the dup pushar, it's basically saving here an index, right? And then the call to -1 is basically transforming this into this. Then we do an over and then a swap, effectively putting a UB here, right?
Right.
Then we do a call to find character, which is basically going to return as a char. Then we check if the char is 0, so this is going to be equality on that. Then we do a pop r, then a swap. So that means that we are putting the index here and removing it from here. Then we do a
Yes.
jump 0 on it, because yeah, that's still okay. So we do a jump 0 to put 1 if it's 0, because we can short circuit, right? But if it's a 1,
Yeah.
what is on the right, on the left, that means that we need to check the right neighbor. Okay?
Okay.
So until now, so what we're gonna go with for the is1 stage 2, this, right? That's what we're gonna be
Yes.
doing. Nice. So then we dupe, push the index to save it, and then we call E0, right? We call E0.
Right.
E0 is going to remove the index and mutate A, right?
Will it? It will, right? Yeah, it will.
And that's why I'm wrong, because I thought it was mutating B. That's the answer. Okay, so then we do a swap because the A is already written because of the interface of right next. So then we do a swap on it like this, and
We call reverse char and then swap again to put the strings back in the correct order, and then we return.
wait. Where are we doing this swap?
Before we do the pop R to get back the index, we do a swap.
Okay, so then when the index goes here, right?
Yeah.
There.
Then
Then we
we
do a
call
pop
reverse
R, then we
char.
do a call to reverse char. Reverse char will receive this nonsense.
Yes,
Over.
but ideally the reverse char shouldn't care about UB, which means that they actually can't use put 0 and put 1 because they assume, yeah.
So then the over will basically generate this. Then we do a call to find character, which is going to put the char here. Then we do a call to equality, so this is going to be the equality check. The only thing that we will have to do is to, between the jump 0 and the jump 1, to reverse it back. As far as we're
Actually,
concerned.
before the jump 0, we have to reverse it back. Or, and this may sound crazy, we could have just say, okay, we jump 0 to a function that doesn't presume that we want to write to something deeper in the stack, and then we jump to something else that also doesn't presume
But
that.
that's gonna be very, very similar to the right next, but without that assumption. And I don't know if I want to do that.
Well, no, the thing about write next that it's mostly just shuffling and then it calls write character, right?
What we could do, which I think would be very... Oh, no, but then we're gonna have the problem of the tail call again. Okay, go back, please repeat.
We could just say, okay, instead of using put 0 and put 1, because they presume that we want to write to a function deeper in the stack, we can just have, functions that write to the string that's on the top.
Yeah, that's gonna be basically boilerplating these three, but without the changing this sequence here.
Uh, what if instead of put 0 and put 1, tail calling write next, they just literally put a 0 or a 1? Oh, wait, but that doesn't work with jump 0.
No, wait,
Uh,
no, I don't think that's the case. It doesn't work what you said, because if we do a call here, yeah, yeah, it doesn't, then that the conclusion is what you said. We need to do a jump because we need a jump 0 because we don't have the call, conditionally. And then to get around that problem, we just tail call that to write next. Like ideally, these two functions should not do the effect. They should only put something.
What
Uh,
if, hear me out, what if put one and put zero took a continuation as an argument?
wow.
And then they put the value and then they jump to the continuation.
I don't think that's a plan, bro. I don't think that's how we should do it. Uh,
Why?
I have a better proposal, I think. My proposal is to get rid of the put 0 and put 1 abstractions whatsoever and just do the literals by hand.
Okay, I guess.
Because having a continuation is gonna be so fucking hard to read after that I don't know if I'm in the mood of doing that. Do you really think it's not gonna be hellish to read it after?
No,
Because we're
it's
gonna
literally
forget.
just push R. No, it's literally just push R in return to call the continuation.
No, no, no. I think you are not understanding what I mean. I think that if we put a continuation in the middle of the process, I think it's gonna get harder to read the entire process when we forget about it.
Okay, that's fair, I guess.
It's gonna be terrible. Um, but the problem with what I said is that I'm not really sure what I said is kind of possible though, because what I wanted is to just put the literal and the jump here. Uh, but then the check zero gotcha is gonna have to also be changed, I think. You see the problem? Because we made the entire thing assuming that we would use jump zero. So we made the check zero to utilize it in that way. Um, because we wanted to branch using jumps. The issue is that if we get rid of it, I don't think we can get rid of the jump because it's the only way to do conditional. So maybe we don't have a choice. We're gonna have to do the continuation thing, which is it's gonna be
What if we
so.
change check zero to actually return not a boolean, but the one or the zero?
Um,
Is there something that breaks if we do that?
yes, 100%. But what about making a clone of check zero specifically for the reverse? That's way less boilerplate and not using continuations in assembly effectively.
It's
Because
literally just a function pointer.
so what you're suggesting is basically the check zero returns a zero or a one. No, but that doesn't solve our problem, right? Oh no, it does. Wait. Um.
It does, because then we don't need put one and put zero. We will just have the zero
Oh,
or the
actually,
one.
we could make a provide opposite. And then instead of getting the thing, we already get the next. And then we just uh, do a jump. Oops. Ah. Oh no, but we still have these on the stack though. But that works. Do you agree with that?
Mm,
But this would have to be a call. Because this is going to be the scenario after if we do it like that, I think. Yeah, we don't need the jump zero either. So it's actually just this. So
Oh, I see.
we
I think
provide
I
the
see. We
opposite of
do
that. Actually, it's gonna be
define the character.
char after the defined character. Then when we provide the opposite, yeah, yeah, that would
Just
work.
just put a char prime to say, okay, this is the inverse of the char.
Sure.
I'll call it inverse char, I guess.
Okay, I think I prefer
And
inverse.
then and then we can just jump to right character, right?
Well, actually not.
Assuming we have the
Wait,
index.
wait, wait. Actually, not really. 1 second. Um, one bleeding edge second. Because I want to understand the thing. Yeah, I want to understand the thing. Just one moment. So we go from reverse char. It has this when we call it. The two overs is to do this. The find character will put this here. The provide opposite will consume that, then do that. But that's
Then
still a
we do a
problem.
swap and we jump to right character.
No, but that's still a problem.
No, it's not. Why?
Because the UBs is still on the bottom.
And that's fine. We're not gonna touch it.
No, we will, because I want to call right next.
No, we can just directly call right character.
Ah, so your plan is to swap, then call.
And then
No, actually, no, this
I
can't be a
think
call. This needs to be a jump. Right character.
yes. And actually that fits in a single word again. So over, call, swap, jump, and then find character, provide opposites, right character.
Actually, this needs to be a call. Uh,
Why?
because we need to, when these things get consumed after the swap, we're gonna have this, and then we need to swap it back. Oh no, but we are
No,
swapping
we don't.
when before returning from is1 stage 2. So this is gonna already be addressed, right?
Actually, there is one minor problem. Right character consumes the string pointer. We don't want that. We really don't.
So we need to dupe before calling it, before swapping, I guess.
Actually, I think
Index
we
and then
can
char
dupe
prime.
before we call reverse char even. Because reverse char now only takes 2 arguments, right? It doesn't take 3 anymore.
Yes.
So we can do in stage 2, in one stage 2, we have dupe, push R, call to is0, and then
This is where we swap the
we,
universes.
when we swap the universes, before popping the index back with pop R, we do a dupe.
Sure. And then this call needs to go here. Right. Right.
Swap, dupe, swap. Actually, I think we can replace swap dupe with an over.
Even better. Then the
And
call
then we
goes
don't
back
need
to
the
here.
swap afterwards. And we have call return, that means we can just use a jump instead.
Call return, we can use a jump. Yeah, doing tail call at this level is completely non-scalable. Jesus. This needs to be done by an automatic process. Okay. So, wait, but now I think I am lost again. So when you do that, you do the swap. You're gonna put the sharp prime here. When oh, but we should have a UA here again, right?
We should actually. That's not quite right because the way we set it up, we should have the UA below the UB because we did an over instead of swap dupe.
But that's... Oh, that's true, I think. Yeah, so the UB is here, effectively. Like
Yeah,
this.
yes.
Then when you write, so then when you jump for the right character, this is gonna do like this, and you're done.
And we are done, yes.
Whew! I wished we tested before writing everything in one shot.
By the way, the swap jump should be in the same in the previous words because there's room for both of them.
Oops. Okay. So now here's the... Oh, wait
We
a
need
moment.
we need to implement
Wait.
provide opposites, yeah.
No, not only that. Not only that. Uh, but we also need to go... Uh, well, let's do this first. So what is going to be the thing? So we have UA, UB, UA again.
Forget
Uh,
about those. We only care about what's the the character on the top of the stack.
that's true. So we call check 0 on it. We call check 0 on it. Again, the same problem. We're going to have to make an auxiliary label again. Because the only condition of the scrap is jump 0.
Yeah.
I'm so fucking sad. Okay, I'm sad. Uh, so let's put a push 0, which is literally this.
And return. Don't forget the return.
Yeah. So if it's this, and then this, and then this. Uh, so
Asterisk 1.
so then it's gonna be this push. Wait, if they are the same, we push. No, if they are
0 means they are 0
different,
means it's not a 0.
so then we push a 0.
Otherwise we just push a 1. Yeah. Enter asterisk 1. We're done.
um, Question.
Yeah.
There should be a place here where I purposely added. Jeez. My mind. Ah. Ah. Okay. I wish. Oh, main loop. Where am I calling this? No. Okay, so we are not calling it. That's bad. Because these are two jumps. So that means that at that point, the main loop should actually call give next value. All right. So let's
Yeah.
assume that this has a UA and a UB from the start. And now we need to put the index on top of it, right? Agree on that?
Right.
Okay. So my understanding is that we need a counter. Right?
Right.
Um, so literal. That's not really what we want, right?
No.
That's not really what we want. Um, So I guess push A, load A.
Yes.
Okay. So we have the counter already in position. So this is in the index. We're gonna
We could
call.
keep the counter. We could keep the counter in the return stack. That's an option as well.
I think this is easier to read. Um oh no, but we do need to dupe it and push to PR though. To push TR that. So this is counter. Because the index is gonna vanish. Uh, Wait a moment. Shouldn't we then mutate the counter region? Oh no, but we will do this right now. Okay, this is the place that we're gonna do that. This is the main loop. I need to remember that. So then we're gonna call give next value, which is 100% effectful. It doesn't change the stack aside from consuming the index. Then we need to pop r. We need to increment this guy, right? So counter is gonna get away from this, and I think we should make an increment counter, which is uh, it should not change the stack. So dupe push r push a load a plus ret, and here.
That's bad, by the way. Do you know why it's bad?
Not yet. 3 6, and then we do a pop r, but we need to do a pop r before this. So the red needs to go
Now it's
here.
not bad anymore.
So we do the pop r, then
That's
we do a call.
that's
Uh,
still kind of pointless though.
I don't know what you mean. That. That. Uh,
Oh, I see. I see.
oh no, actually it depends. What is easier? I have a feeling that the other way is easier. We have the opportunity to start from zero and go to generation, or we start from generation going to zero. What do you prefer?
I prefer to start from zero. Ultimately, it doesn't matter because we're going to build the entire universe before we print it anyways.
No, it matters because of the jump zero. That's what I'm afraid of. Because if we go from jump zero, we don't have to use some equality checking ourselves because we can just rely on jump zero.
Um, I still prefer starting from zero because we start from zero, right? And then after we are done, we increment the counter to 1. And then we check, okay, jump 0 to see if we're done. And when we reach the end, at some point we are going to have to do some masking to make sure that the counter properly loops when we reach the end of the universe. Um,
No,
and
no, no,
when
no.
that
But that's no, no,
happens,
no. But that's you're going too far already. Because we don't have to utilize the entire universe. Let's suppose the generation is 15.
what do you mean?
Oh no, there are two loops. I forgot about that. That's true. Okay, go on.
Yes, so we start from 0 and then we increment the counter and do the
Actually,
bounce
before we
checking.
continue, I want to ask you which counter are we talking about? I was talking about the outer counter. I believe you
I'm
were talking
still
about the inner
I
counter.
Yeah, I'm talking about the inner counter.
Okay. So I think we need better naming. So this is gonna be the
Don't we already have a variable called generation somewhere up there?
no, but that's a compile time value. That's not something that we're gonna mutate upon. My plan is to do something like gen counter generations, and then the universe counter. Maybe this is better. Do you agree?
Okay.
Okay. So do you agree that the outer maybe it's better to not start from zero?
Oh, the outer is not going to start from zero. It's going to start at whatever.
No, 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 no. Let
Because
me change my sentence. Do you think it's gonna be easier to implement the outer loop starting from zero to generations or from generations to zero?
from generations to zero.
Okay, in that particular case, we will. This is still gonna do the thing. This is still gonna do the thing, but this is gonna be a call, which is to -1. And this is gonna actually gonna be decrement gen counter. And this is the counter that I was referring to before. So gen counter. So decrement. And I did like that because it's easier than the other counter. The other counter you're gonna have to loop around or check boundaries or whatever the heck. I was going for the easiest one first.
I see. Oh, in
So then
that
we
case,
jump zero on this, and then we do
no,
something
no, no, no,
else.
no, no, no,
And this is
no,
gonna
no,
be
no. We
the
don't
end.
want to do jump zero. We don't want to do jump zero because this will. Oh, right. We have an actual storage location for it. Do a jump plus, maybe. No.
No, I think this needs to be jump zero
Um,
because if the gen counter reaches zero, we should do something else, which is the end. And the end should basically be halt. Um, Now, with that out of the way,
I was
uh,
actually thinking of saying, okay, jump plus goes back to the main loop, and then the
oh,
ending
but I need to
codes
dupe
goes
this
after the jump.
before jumping zero. Repeat the last sentence, please.
You know, I thought that instead of doing jump zero to the end, we could do a jump plus to the main loop instead.
Jump plus to the main loop. What does the jump plus do again?
Jumps if positive.
Sure, but that consumes the thing as well, right?
It does.
Okay, so this can be a jump plus, and then halt. Sure, even better. So this is gonna
Yeah,
be
in main loop.
update universe.
No, no, it's gonna be main loop.
This is the main loop. So we're gonna have this.
No, 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 you don't get it. You're doing jump plus to update universe, so it's going to update the universe once, and then you're gonna halt. Oh, I mean, oh, I see. You want to make the update universe overflow into the main loop. I thought we were not gonna do stuff like that.
I didn't think about doing that, and actually we can't because oh, actually we do can. We can if we remove this because the first thing that we put is put that on top of the stack again in the beginning. We can do that. I was not thinking about doing it that way. You caught me off guard in that regard. Uh, but my plan was like, if it's positive, go to update universe, and then update universe will do something to get back to main loop, maybe jumping to it. because the update universe doesn't care about the outer counter at all, which is cool because the jump plus now can get rid of it.
Amazing.
But that is a problem. We need the other counter in between them. Um, which I guess it's easy. It's just literal. Uh,
No, no, you can put that
universe
inside of
counter.
updates universe.
Oh, that's better.
Mm.
That's even better. So gen counter is completely gone, and then we just do literal. Oops, not that. We do literal, and now you have the universe counter.
No, the literal is just 0.
The literal is just 0. I don't understand at all.
Yeah, because we're going to start from the beginning of the universe.
Yeah, that's
We're
what it's
going to
saying here.
iterate. Then we're going to iterate through the length of the universe.
Yes.
And then we're done, and we can get rid of the counter.
No, but then your argument comes into play because then we are talking about what you understood before, which is, do you want to start the counter from 0 and increment, or do you want to start it from the
No,
max
no, no,
and
no.
decrement?
What I'm trying to say is that okay, the literal is going to be 0 at the start of update universe, right?
Wait, what?
And then like the counter is going to start at 0 at the beginning of updating the universe, right?
Yes.
Then we're going to loop over the 2 universes until we reach the end, right?
Yes.
And then we're done, and the counter can reset to 0 the next time we update the universe, right?
Yes.
Do we
Oh, so
really
we don't
need an
need
actual,
this. No, no, no.
yes, do we really need an actual variable for that? I don't think that we do.
I think we do because I don't know how we're gonna. Oh no, we don't. We don't. We don't. And something else that we're missing. We need to print the universe, friend. And there's a problem because we cannot return to the main loop because the jump is it is a jump plus instead of a call. Again, the same problem with the jump 0. Um, okay, so we're gonna do something forbidden, at least in game development, which is that the logic of the game and the visualization of the game will be bounded together, I guess. Because we can before finishing update universe print it.
No, we can print before updating, I guess.
That's still something that we should not do. Uh, but I guess that works. So we're gonna
This is
do a
not a,
call.
this is not actually a game though, because there's no input.
It is a one-dimensional game of life, so it's kind of complicated to argue.
But the game of life is not actually a game.
Um Stonks.
It isn't, because what you do is okay, you set the initial conditions and then you start running it, and then it just does its own thing. You don't have any input.
I don't know if the definition of a game is that it requires an input, though. I don't know about that. I really don't. But that doesn't really matter to me, actually, because, well, I actually think it's pretty neat to try to keep your logic and your visualization separate. I think that's neat. But given that we are facing the same goddamn problem of the jump 0 with the jump plus, I'm fine. I want to check what is the interface of print universe though, so it assumes that the universe is already there. We always print the B or the A, I already forgot. I think we always print the one that is on the top, because update universe will also swap, right?
Yeah.
Sure. Uh, I think that's fine. Yeah. I'm really concerned about the swapping of the universes happening with the utilizing E0 here. Oh man, I think we're gonna have a bug on that. But let's go. So we're gonna do a call to print universe, and we're gonna print the universe
But
that is on
Lemos,
top of the stack.
Lemos,
Sure.
E0 is not actually swapping them.
E0 is not swapping them, but we are swapping them ourselves. Pay attention to that.
No, or not.
Yes, we are, because at some point the interface of reverse char, it is not. Wait. Oh, when we swapped the swap with the Nover. I see. Okay, okay, maybe you're right. Maybe I'm stupid. Okay, so we're gonna do a call. Is the print universe? Yes. So it is doing a jump, which is gonna do the return. The print new line is gonna do a jump to the right, and the right is gonna do a return. Tail calls for days. Uh, so then we do that. Then we put the 0 in here, and now what do we do now? We need to jump the size of the string. How do you know the size of the string? It should be the beginning of the
Two things.
pointer.
Two things. First, um, we probably want to dupe the universe before printing it.
But the printing doesn't consume it, as far as I can tell.
Well, it calls
Call.
write. I'm pretty sure write consumes it, doesn't it?
Uh, it depends on what we implemented for syscall.
It does.
It does. You're so certain about that. I'm impressed. Uh, you said that it does. Pop, pop. Um, yes, it does. We do not put that back in. So in that particular case, we need to dupe it. Yes. So let's go there. Okay. Dupe. Sure.
And we also want to pop the return value because it returns the number of bytes that it wrote.
And why do we care?
We don't. That's why we pop it.
Oh, okay. So pop R.
No, just pop. We
Pop.
get rid of it. I think that the instruction is actually called drop, if I remember. Yeah, it's drop, right below dupe.
Yeah. Okay, we are officially on the 2 hour mark, but I think we should go on because we are in the pace. We are in the momentum. And we're not that far off. We are not that far. Go on. Hello? Marinho?
One moment. So
Okay.
we just printed B.
We just printed B, yes.
We just print. We just printed B. Which means we should probably swap the universes here, actually.
Okay, so
Before the
before,
literal 0.
sure, makes sense. Actually, whatever. If we do in the beginning, do it in the end. I don't really care. I'm fine.
Then we push the literal 0.
Okay, I should not. Just a moment. Uh, there, go.
Oh, wait, but if B is the one that we printed, that means it's the current universe, right? Which means that actually we should do the swap at the end. Never mind. Remove the swap there, and then let's start, actually. So literal 0, that's our position counter. It's going to be the index. So hmm,
I think we need to uh, put the
okay, we
0.
have the function that gives the next value, right?
Yes, we have the function that gives us the next value. Although we are already using it.
Yeah, so here's what we're gonna do.
Oh no,
We're
wait.
going
No, 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 no,
to
no, 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 wait, wait, wait. I said bullshit. Because I think before I did BS, the give next value should not be here. It should be in the inner loop. It should be somewhere
it should be in
here.
the inner loop. Yeah.
So I did BS. So this is putting the gen counter on, is duplicating it, pushing to R, then push a load A, so we are dereferencing it. So we are getting the 10, the 15, who cares? Then we do a call, which should not be here. This call is wrong. And then we do the pop R to get the counter back in. We decremented the jump plus will jump if it's not 0.
I don't think we need the push R and the pop R, actually.
You think we don't need it? I think we do for getting the current value and then to decrement it.
No, because we are grabbing it as a literal, and we're copying it, right?
So your suggestion is to
Just do a dupe. No need for the push R and pop R. Just do literal dupe push A load A.
dupe push a load. That's
Oh, I
assuming. I don't think that's
yes,
what we
literal dupe
want.
push A load A swap. Actually,
Wait, what? I don't
actually,
follow.
no, I forgot for a moment that we're doing a load A. So push R and pop R actually do in fact do something. Um,
Wait a moment. So in the beginning, what are we calling from here? We provided in the stack this from the entry point. We put the counter address in here. Then we dereference it. Then we decrement it. And decrementing it doesn't remove it from the thing. Right.
we do actually need to do a dupe after the
Oh yeah,
literal.
yeah, yeah. We need to do here because we need to have the thing ready for the thing. So we already have the value though. So the decrement gen counter can be just a matter of doing doing a call to -1. Um, Doing a call to -1. But we need to mutate the counter region, right? We need to mutate the counter address. Agree?
Do we?
Yeah, because the call is only grabbing this value and doing that -1.
Right, we do because we're doing a jump plus. That's correct.
No, no, forget the jump plus. I'm not there. I'm in here. This popper is also not useful. So I think we need to mutate the thing. I think there is a load something something. How can we do it? Do it?
It's star A.
Okay, so no, but then we need to do a push A. What is the?
No, we don't because we already did a push A.
No, we didn't.
We
This is
did.
just dereferencing it. When we do the call, this is on the stack. This is on the stack. When we do the call, this.
Yes, and the counter, the address of the counter still is in the A register.
Oh, so it's a star A, like this.
Yes, and
That
actually,
removes it from the top though?
it does.
Okay.
Uh, okay, so we don't need the dupe actually, do we?
Yes, we do. Wait. Yes, we do.
The
Yes,
dupe, the
we.
dupe should go. Hmm.
Oh, that is why we had the pushar before. Because we need to. Uh, wait. I'm getting tired. What do we need to do? Let's assume that the push A is already. That's a very bad assumption. We should not do that assumption because we are making the context between two functions like shared because it's both of them are assuming that the A register has the counter address.
We
Terrible.
can inline the other function. That's fine.
Okay, that's less bad. So we put that literal there. We need the push A load A to do the reference. So then we do a call to -1. So then we're gonna have a -1 here. Call to -1. Is
Also
that
minus
it?
one. And then we do a dupe and story.
Wait a moment. Then we do a dupe and store A. Then we do a dupe and a store A.
And we don't need the call to the decrement gen counter because that's not going to exist anymore.
But unfortunately, I have many other things in here. So 1, 2, 3, 4, 5, 6. So this goes here.
And the update universe is after that. Yeah.
Whew! Okay. We are okay. So now UAUB, we are dupe the UB, then we print the UB. That's gonna put how many things we are not interested, so we drop it, and then we put the 0. Awesome. What's next?
Mm,
Are you sure you want to start from 0 this thing? Because I think, well, I don't know how much trouble we're gonna have doing the wraparound that you're suggesting.
the wraparound is just an end with a mask.
True, but if we start from 1, we don't have many masks. So that's that.
But the mask is always the same because we're implementing modulo 128. That's the length of the universe.
Okay, what should we do next?
Actually, let's do that next. We should implement a mod universe function.
Okay, so mod universe. What this function should do? Tell me.
Right, it should push the literal 127 because that's the length of the universe minus one.
That's kind of not ideal
We can make that a compile. We can make, well,
because the length
we
is
can't
whatever
really
this
make that.
is.
Yeah, we can't really make that a compiler constant because,
They can mismatch, basically.
yeah,
Although these guys have that information.
they do, but we're trying to bank on the fact that this is a power of two, so we don't actually have to implement division because that would suck.
Because that would suck. Okay. Okay, so let's do the dummy way first. So we want to put 127.
And then we just do an end and return, and that's it.
Okay, so we have the mask. What's next?
Um, we wanna do a dupe
And I just
to
noticed this should be
duplicate.
not this name. This should be update because it's already doing the side effect.
Okay,
This
first
this
of
is
all,
so not me because it is so mutable. Go on.
we want to don't continue the previous word because we have dupe, call, drop, literal, right? That's the setup for the loop, essentially.
Wait,
Uh,
wait. Could you
the
what
inner
repeat
loop,
from the
I mean,
beginning?
we're
What do
setting
you
up
want to
the
say?
inner loop. Yeah, because when we call update universe, we're setting up the inner loop first by printing the current universe and then pushing the 0, which is the loop counter.
Yes,
So
yes,
we
yes.
actually want so we actually want to continue on to the next word, even though there is room in the previous one, because this one has to be the another label. It has to be the universe loop, the inner loop.
Oh, so you want to make a update universe loop.
Yes. No,
Okay.
no,
So
no, no. That goes inside of the update universe.
that goes inside the update universe.
Yeah. So what we're gonna do is we're going to duplicate the counter, and then inside of this loop, we're going to have the index at the top when we begin. So
But we duplicate before joining entering the loop?
no, before entering the loop, we printed the current universe, and then
Put the
we
counter, then we dupe,
dropped.
then we nop nop. Actually
No,
no
no,
nop.
no. You can just have call, dupe, call, drop, literal, and nothing else afterwards. Because if we don't put anything else, that's going to be the instruction to fetch the next instruction.
Oh, that's true, that's true. I think you already tested that for us, right?
Yes.
Okay.
Um, right. So the first thing we want to do is we want to duplicate the counter. So dupe, and then uh, push R because we want to remember the counter.
Wait a moment. Sure.
Mhm. And then we want to call update next value. So call here. Then we do a pop R. Then we add 1 to the counter. So literal 1 and plus. And then we want to call mod universe to make sure we don't overflow.
So call.
Uh, then we do
Wait a moment.
yeah,
As far as I can tell, the update next value function assumes UAUB index.
yeah.
It doesn't know how to wrap around.
We will have to fix that, but let's finish this loop first.
Sure.
So we updated the next value.
Oh,
Then we
that is
incremented
why
the
I wanted
counter.
to do a function with 3 arguments, bro. and not the universes. Because then the responsibility of wraparound would be here and not in the function.
But the function will have to, well,
That is why I wanted. Now I remember. Anyway, it's already done. Go on.
okay. So we incremented the counter. We did a mod universe to make sure we don't go to an invalid address. And then we have to do a dupe and a conditional jump because after we increment the counter, okay, there are two possibilities. Either we have a positive number, which means we should continue the loop, or we have a zero because the mod universe will have caught an overflow.
Yes, I
In
follow.
which case we can just continue on into the rule 110 loop.
So it's a jump 0 here.
So it's actually a jump plus back to the universe, update universe loop.
No. So jump, and then the first one is going back from to here, and then the other one is rule this.
You can get rid of the jump because they are just in sequence.
You
So
know what I think about it. You know.
okay, and
Uh,
that's the loop done, I think.
okay, so but now we need to upgrade update next value to do wraparounding.
That's actually pretty easy. We just have to. There's precisely one place where we add one, and another place where we subtract one when we dereference
Okay,
the
so here's the
character.
plus.
Yeah, so after the plus one, we have to
Um,
do a
I'm
call
actually gonna suggest, so this is
to.
gonna be a right neighbor, and we're also gonna have a left neighbor. And this is not how you write neighbor. Is it like this?
Depends. Are you British?
Um, Whatever you prefer. Let's say like that. What do you prefer?
I prefer not being British actually, because
So,
there are fewer letters, and
okay,
only because of that.
so like this.
Yeah.
Okay, and let me already find the left one here. This is gonna be left neighbor. Sure. Let's implement these guys. As far as I can
A left
tell,
neighbor is just
wait,
all minus one, and then what?
we're gonna assume that there is a number on top, and that's it.
And that's it. Yeah.
So we need to check if this number is 0. That's the first
Why?
thing. Because if the number is 0, we're gonna go straight up to 127.
Which means we can just do minus one and then mod universe.
That is correct, in fact. So call, call. Actually,
All
jump.
jump.
So
Fail call.
-1 and mod universe. Does the order matter? I don't remember that implementation detail. In our
It
program,
does.
it does, right?
It does matter.
Okay, so
The minus one or the plus one has to come first.
okay.
Oh, that no. In terms of the labels, the order does not matter. It can
Yeah, I
be anywhere.
suspected not, but for readability, I think people are already used to it like this because of C. What are we gonna do in terms of the right neighbor though?
Literal one plus and then jump to mod universe.
Um, okay,
By
Okay.
the way, there's a literal after in the E0 function that you have to get rid of because you substituted the plus with the call to right neighbor,
Oh, that's true.
but there was a literal one before.
So this is now 5.
Yeah, that's
And
fine. That's fine.
jeez. Okay,
Oh,
so
the find character. Oh, the find character it has to move up a word.
it has to. Good catch. Okay, so are we ready to see how bad it is? Uh,
I guess.
because, dude, this has so many ways to go wrong. And I am really, really suspicious. Like, more suspicious than I usually am. And it's done, bud.
And it broke. How amazing.
It's completely done, bud. So let's try to understand from the top. So we have the main, which is literal, literal. Oh, we have to swap it, right? We
Right,
after
you
we are done,
do.
we need to swap it. Remember that you decided to do that, not in the beginning.
Yeah.
Okay, you have to swap it a bit before going to the main loop. And that is another gotcha. I have a strong feeling. Well, this is definitely not the
Did you
problem.
remember to build? Did you remember to build?
Yeah, yeah, no, we already have it. Yeah. So this is already running. That is expected, but I'm still confused. Uh, because a game with no life, all the no, this is still wrong because it's not printing it 15 times.
Yeah.
So it is still fundamentally wrong. Ugh, I'm so sad right now. Why? Okay, so let's put 1. Let's actually put 2 here. Okay.
Build. Just build. You have to build first.
I don't have to
Oh
build.
wait, you don't actually.
Yeah, we are using our compiler, friend. I know that's weird, but we are using the this is our programming language. We are basically at that stage. We are debugging our own programming language with our compiler. That's what we're doing. So there's no build. Uh,
Right.
the
I forgot
problem
about that
though
for a second.
is that it is printing nothing. It is printing nothing.
A
It
whole lot of nothing.
it prints the first time and then it doesn't print anymore, and I don't understand why. So do you have any guesses?
Mm, well, we can rebuild the Chime machine with debugging, with logging.
That's definitely an option. Actually, that's the perfect option. Thank you for reminding me that we did that. Oops. But I actually have a question. Is minus
Yeah.
one impure?
No, it's not.
So that's the problem. Well, actually, if that's what you said is true, we're gonna have a different problem later. Because if minus one is not impure and it assumes that there is a value on the stack, we are not mutating it. Gen counter. We should. Oh no, but we are doing a
But we
dupe then a
are.
store A. Okay, so then we are doing it. So forget what I said. So let's add debug information. Now we do just build and then that.
Okay, we did stuff.
Oh yeah, I don't know how useful this amount of deep logging is, but we did stuff, in fact.
We did surprisingly a lot, actually.
Actually, that's not true because it's showing that we did a lot because we are basically doing a bunch of writes, uh, like write and find. And this is the logging of that too, because we don't have granularity in that regard, because we don't have an IDE for Chime. So this is basically like probably a bunch of things that we're not interested in, because we know find character and write character works. But it is mixed. So I think we have a bigger problem now. Yeah, this 100% filled my buffer. So I can guarantee you that a lot of these we don't care.
Can we output to a file instead of just outputting to the terminal?
Um, I think we're gonna have to implement that, bud.
No, I mean redirecting the standard error to a file.
Oh, okay. So just doing well. In this case, we don't need, and this is gonna be something like output txt.
Yeah, no, I mean standard error, not standard output.
Standard error. I don't understand.
Because the log outputs to standard error, not standard out.
Oh, okay. So what is the? Do you know the symbol here?
I think it's ampersand 2, if I'm not mistaken. But I might be mistaken. So there's that. I think
What?
it's actually might be just 2 instead of 1% 2, because I just recalled that ampersand is to put a pro uh oh, that worked. Is to put a process in the background.
Okay. There it is. So how many lines is this?
Nice.
41,000.
We did a lot of stuff before exiting, even though we didn't print what we wanted.
41,000. No wonder it filled my buffer. Now what?
Okay.
Now what?
That's a good question. That's I didn't expect so much output there. Okay.
And this is only two iterations, right? Because we only ask for two generations.
Yes.
But I don't think 20,000 is gonna help if we cut that in half.
Try to do zero actually. Zero generations.
Well, let me first remove the... Oh, actually, we don't need to remove because we can just do this all the time. There. There we go.
Right, now let's look at the output and see how many lines that is.
Probably a lot. 18. This is what we did. Let me put the program here. And by the way, this is a 200 lines.
Yep, that's a pretty long program actually.
This is very long of a program, yes. Okay, so what we do, PC fetch literal, calling. Makes sense. Then we go to here, to here. Then we do fetch literal, push A, load A, calling to the -1. I'm gonna assume that the -1 is returning here, and it worked. Then we do a dupe, store A, PC fetch, which is a jumping plus, and then halt,
No,
which
no,
means that we did a
this
jump.
we didn't jump, which is correct actually, because 0 is not positive.
0 is not positive. Oh, we can decrease the size of the universe to have less
But
instructions.
then we're well,
Yeah,
but
then the mask is broken. I understand.
then the mask is broken.
But then we can do a power of 4, a power of 2 again, like 4. What do you think about that?
Let's. Why do we want to increase the size of the universe?
We want to decrease it because then this loop may be readable.
Okay, that makes sense. In that case, yeah, let's do 4. Just for the sake of our sanity.
41,000.
And
That
then in the mod universe, instead of 127, it's just 3 actually.
done. Actually, let's not.
Right, and then
No. But let's actually do that. So universe size, and let's use this constant in here.
that doesn't quite work because it's 1 less than that.
Okay, so let's just do what you said. So let's do universe size call. Is that it?
That is it, yeah.
Awesome. Okay, so let's run again.
Build, don't forget to build.
We don't
Oh
need to
wait, we don't
build.
need to build, never mind.
We
We
don't
forgot
need.
to change the number of generations to 1.
I did.
Oh, there it is. Okay,
Did I
okay.
save it? Yeah. Yeah, and it's not printing, which is bad. Uh,
Open the output. Open the output.
it's wrong. Oh, we are decrementing it first. We need to decrement it last.
Yeah, that is actually a mistake.
Uh, but then we have a problem then. Push load. Oh, it's after the push load. So then we do a jump plus here.
Oh no,
Uh,
actually, that doesn't quite work.
no. Still gonna do the jump plus, but then we're gonna have to do a jump 0 to rule 1 on O loop again. So then we call, then we dupe, then we store. 1, 2, 3. So the store needs to go in the other line. So this is where we save it. And then we do a jump 0. Uh, and then halt. And then this needs to go. Yeah, this is still. No, this is wrong. This is wrong. 1, 2, 3, 4, 5, 6. That. But we need the gen counter to be here. The update universe. And the address is rule 1 on old loop.
By the way, that doesn't quite work because update universe clobbers the A register.
Uh, wait, what? And why does that matter?
Because we're doing a store A after we call update universe, at which point A does not contain what it had before.
Ah, I see. I see. So then we're screwed.
Oh no, we can just grab the gen counter again and do another push A.
No, but we lost the value. That's what I'm saying. When we did the jump plus, the new value. Oh no, this is the old value.
Is the old value, yes.
So before doing the call, we need to do another literal. Oh,
That doesn't quite
that's.
work either, by the way, because we're not decrementing the counter before going into the loop.
Doesn't matter. We're gonna decrement it right now. I'm gonna do this.
No, you don't get it. If the counter is positive, we're going to jump plus into update universe, right?
Yes.
And we're going to do that without decrementing the counter, right? The
And now we're
generation
gonna
counter.
decrement and go back to the beginning.
No. We're going to do that. We're going to jump into update universe without decrementing the counter beforehand.
Which is not a problem.
Which is a problem because update universe is going to jump back to the rule 110 loop. And the counter will still be the same thing as it was
Oh, I
before we
forgot about
updated the universe.
that. I forgot about that. So we need to do a call instead of a. Oh, but the jump plus. We are utilizing the plus of it. Oh, I want to die. What is the solution to this problem?
Um,
Okay, there is a solution. You're not gonna like it. And I'm gonna hate it for that matter. Uh, Actually, this is not what I want. Oh, it's even better. There. There.
literal plus. That doesn't work either.
I think it does. I 100% think it does. Do you want to try it out? Oh, it doesn't. Wait. Am I doing this right? Oh, I didn't save it. Oh yeah. Totally works.
Wait a moment. Gen counter is literal plus.
But I
Push
think
A, load A.
there's something wrong because there's an empty line here. So I think it's printing something that it shouldn't. But it is printing the one that I wanted. And I can explain
What's in
why.
the output?
Let's
What's
see
in
the
the
output.
output?
No, but do you understand why that worked? Oh yeah, it totally worked. Woo! 160.
Yeah, no, it didn't.
What it didn't?
It didn't work
No,
because
it did. For the purpose of what we wanted, which is to you put one generation and it prints one generation, it worked. That's what I wanted from the
it
start.
didn't. But we didn't because look, we're doing a literal of the gen counter, right? The address of the gen counter. We're dereferencing it, right?
Yes.
Which means that we have a value which is a number that represents an instruction word.
Oh, you're right. I am tripping balls. Okay, so then I don't know how to solve this. Because we need to decrement first, correct?
Yeah.
But if the value is 1 and we decrement first, it's going to be 0. So you need to put the number 2 to actually have a number 1. And that's okay, but from the user's perspective, that's terrible.
We're off by 1.
We can do a +1 here, I guess. No, that's not going to work
Here's an
either.
idea. No, here's an idea. Here's an idea. Currently, we're printing the universe inside of update universe, right?
Yes,
What if we print the universe before we update the universe?
that's also fine. So you're
Because if we
saying
do
to
that, we
basically
can.
do a dupe, and then the call, and then the drop here.
Yeah.
So boom, boom, boom.
Oh, actually, no, that's not quite what I had in mind. Because uh,
I think that's what you had in mind, sir.
I'm trying to think of a way to say. Call, loop call drop to print the universe. Then literal gen counter, push a load A. Yeah, yeah, okay, that works. Actually, that works. Because what I was thinking is say, okay, the gen counter tells you how many times we're going to print, and we say, if we just say, okay, the minimum is 1, because we actually, the way we wrote it, we can't have a number less than 1 there. I mean, we can, but it's going to print 1 anyways.
Sure.
Yeah, I think that works. I think that should work.
Okay, so in this particular case, we should have it. Yeah, we have it. But this is wrong. Agree on that? I think we can confirm with the output. Yes, I want it. Yes. 180. And I asked for 1. That doesn't make sense. Do you understand why? I think it doesn't make
Because we
sense.
printed the
Oh,
universe
there's all
once.
the calls for writing to the thing.
Yeah.
Yeah, but do you see that this is doing extra stuff? They should not do that. I think the print universe is broken. Let's take a look on that. So when you set the new line, oh, set the new line also calls
A bunch
write
of stuff.
character. Is write character doing side effects aside from what it's supposed to do? No, it's not calling a syscall. It is not calling write. So that means that we should be fine.
I think we should do the set. We should set the new line just once at the beginning of the code, and that should reduce the outputs of the log.
That is true. So then I'm gonna pick this and pick this. Actually, I'm gonna do this here. So call there.
Yeah.
I don't know how to do this the other way, so I'm gonna do output. Yes. 180. I guess that makes sense. We are doing a call and this is doing a return. We just changed where that's happening. Especially because we are printing only once. This would make a difference if we were printing more than only once. We want to only print once. But I want to understand
Yeah.
first why we're printing this empty new line. That's what I want to understand. So to print the universe, we call the right syscall, and the right syscall assumes that you provided what you want to print, which I think we did. And it is putting the new line and then doing a jump to that. Interesting.
Where are we printing the universe actually?
Down here. We do a dupe of the the top
Oh,
universe,
okay, okay, okay.
and then we print it. And actually, I want to halt immediately after. So dupe call print universe. Yeah, you see what's happening here? So the print universe is printing an empty new line for whatever reason. Okay, let me save the load that I have on my buffer, and I want to remove uh, this guy, and the print new line is calling a write. Okay, let me actually copy this, and let's remove that. Let's put a jump. Let's remove that. Okay, very interesting. Very, very interesting. Do you agree, sir? Do you agree? How is that possible? Did you understand what just happened?
Yeah, we write, and apparently we're writing a new line as well, even though we shouldn't, apparently.
I think I know what happened.
What
I
happened?
think the right syscall is already adding the new line, and we didn't have that perception before because the std error was mixed with the std out before.
But it shouldn't. We're actually writing literal bytes to the standard out.
Yeah, but I don't
And the bytes that we are
understand.
passing don't include a new line.
Yeah, I understand that. Okay, let me put this other version in the wherever I'm saving it. So samples nothing. Oh, of course. No, that doesn't make any sense actually. Oh, I did sample samples because I am stupid. Wait, how this? Oh, the SDR error got changed. Yeah, I think it's adding a new line, sir.
Huh. Okay, that's not good actually.
Well, it's convenient, but we're gonna have to deal with that later. Because in this particular case, uh, yeah, we did all of all of that for nothing. Well, it was not that much work anyway, because this is now useless, and then we can just put the load A back in, remove the halt, and just do write. Yep. 168. Yep. Checks out.
Okay.
Um, okay, so now we can try to understand what the heck is going on. So, uh, uh, where is the jumping plus? Because we did fetch literal, fetch literal, fetch literal. Oh, we are setting the new thing. Okay, so I'm actually gonna remove that because it's not useful anymore. Sure. And I need to discover how to reread the buffer without doing this nonsense. Okay, much better. Let's go now. Okay, we're not gonna finish this today, unfortunately. We're so fucking close, though. I can feel it. PC fetch, because we're gonna reach 3 hours, and I think that's enough. So PC
Yeah.
fetch, fetch literal calling. Nice. Then we do a dupe, a calling, there, returning. This is where we finish printing. Then we drop, we fetch a literal, push load a PC fetch. Then we call -1, returning from -1. Yeah, and that's it, actually. So do you want to try to do with 2 generations?
Let's do 2 generations. Yeah.
Okay. Boom.
Oh, there actually isn't a new line.
Okay, so you just okay, so we just discovered that we need the new lines between the universes, right?
We do.
That's a problem. But that doesn't matter
Why is
actually.
there an implicit new line at the end of the program though? That makes no sense.
I have no idea. There's a
Ah,
chance this is my
this is
terminal though.
terrible.
Yeah, there's a
Ah, this
chance this
is
is my terminal. I'm not gonna habilitate and I'm not gonna put the new line in there. We can do that once we get it right. So output. There we go. So 1369. Pushing to A. Load A. Wait, down there. Load A. This is the -1. Dupe, store A, jumping plus, and then the jumping plus does a literal,
it's
and then
doing
yeah, it did to
it's
it
doing a
went to
piece.
here.
Yeah, it went there.
But why is not printing? Oh wait, that's actually a lie. Now it is printing. So maybe now we should try to make something happen here. Give me a one in some position of the universe. I don't remember which
It
one.
can be where the cursor is. It can be where the cursor is.
Like this.
Yes, like that.
So
And I
do
think that may actually be the wrong universe to put the 1 in. It should be in the B, I think.
so let's put there. I have no idea if that's correct. Absolutely
It's
no
not.
idea.
It's not.
Why?
Because the one should have propagated to the left. The second generation should have 2 1s.
Oh, I see. It seems that nothing happened though.
Yeah, it does.
So something is wrong.
Change to
We,
3 generations and let's see if that makes a difference.
nope.
Still doesn't, yeah.
So, or we did something bad with the stack, or we are not swapping the correct place. Let's assume the easiest one, which is the swap is in the wrong place. So, the swap is on here.
Dupe, jump plus. Oh, we're missing a drop after the jump plus.
Why?
Because we just duplicated the index, which is needed inside of the loop.
So,
But actually, we don't want the index after we leave the loop.
yes, we don't. We actually don't. Oh, okay, so there's more ones in there now. So let's actually go back. Is that what we expected?
It is the one propagated to the left, as
And
it
I
should.
apologize, my brain is fried right now. I spent all my energy keeping up with you on this thing. So, we need to add the new line though. Um,
We do.
um, it's here. It got worse. Am I tripping?
Uh, 1, 2, 3, 4, 5, 6, 7. There's 7 instructions in that word.
Oh,
There should be only 6.
and this is still wrong because I also don't care. Wait, depends if the print new line is doing the drop. It is not. So we're also gonna drop after calling that 3 3.
We should really do the drop inside of the print new line, actually, because it's always going to. Well, that's not
I think you
necessarily
have
the
a
case,
point
is
though.
it?
I think you have a point. I think actually I'm gonna recreate print universe just to do that.
Okay.
So this is that, and this is. Oh, okay. So we're gonna have to do a
No, no, no.
call,
Just
drop, ret.
call, drop, return. Yeah.
I know stuff. I know. Okay. I know you know more than me, but I know stuff. Universe. The argument needs to be provided beforehand. There. Now, get rect 3 5 load a. Perfect. Ah, it's still wrong. What am I doing wrong? Uh,
Let's see. We print the universe. We print a new line. Are we dropping the results of write in the print universe?
no. No, 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 we are.
We should. Call, drop, return. Yeah, we are. So dupe, print universe, print new line.
Did I save this? And it's not working still? What? Um, what?
No, that's actually correct.
No, no, that is, but that means that this call is broken. Am I
Uh,
counting this wrong?
did
This
you
is
remember to
6.
set the new line at the beginning of the program?
No. Call.
Call, set new line. Yeah, call, set new line. There we go.
But now it is doing the thing again.
Ah,
Oh, it's
change
because
the
we
generations.
always print that.
Yes. Now make
Uh,
3 generations and let's see what happens.
no, but that's bad.
No, 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 no.
Because.
Change to 3 generations first.
Okay. I have no idea. I'm gonna pick the table here. Um. Oh, it's wrapping around. Ah, I don't want to do it. I want to die.
No, but that's wrong. That's wrong. It should be 3 ones on the next generation. The one should only die after it propagates.
I want to check one thing. One, yes. 100 should be 0, and 001 should be 1, and that happened.
Yeah, I think the case where it's 011 is wrong. We should look at that.
So, um, if it's 1, is 1, there.
It's
And
one.
we are
Left
doing the
neighbor.
left neighbor. Is this the case where the left neighbor being 0 matters?
Yes, if the left neighbor is 0, check 0. If it's true, oh, we should put. Ah, that's backwards. What is it? Well, check 0. It will return true if it's 0, which means we will not jump.
No, wait, what? No. Let me try to repeat that again. Uh, uh, we know the middle guy is 1, and we know that the left one is 0. Does that matter? Do we need to look into the right guy?
We don't, but we are.
0, 1, 0. What is 0, 1, 0? 0, 1, 0. It's also 1, so it doesn't matter. So in that case, I am tempted to just do this. There. Are you happy?
Okay, now bump to 4 generations now.
You know we're not going to be able to see the entire effect with 4, right?
Actually, we should see something interesting with 4.
No. I think with 4, the size of the...
It works. It actually worked.
So, are you ready?
I guess I am. What are you gonna do?
I'm going to put 228 and grab uh, the original string that we did. Because I already forgot how to do the macro thing. I should make a shortcut to like repetitions of characters. There. Okay. Boom. Boom. Now the question is,
And
how should we start
put a
this?
one, put a one somewhere in the universe B.
No, not somewhere. I want to achieve the pattern that we see on the image on Wikipedia.
Wow, in that case, you should put the one on the far right as the last thing.
The last one, like this.
Yes, the last one. Yeah,
Are
like
you
that.
sure not
Like that.
the
Just
this one?
it doesn't make much of a difference, but put it on the one on the far right just to be pedantic, I guess.
Okay,
Why did it stop?
because it's
Oh, because we only have 4 generations. That's
yeah.
right.
It's slow as fuck though. I just noticed. I'm starting to think that 0 was a bad call. I think underscores would be better. Do you agree?
I guess, yeah, that would be better. Let me grab the ASCII codes for underscore because we're gonna need that.
Yes.
Okay,
Uh,
it's 95 instead of 48.
so I want to replace 0 with this. And do you think this would be better?
You can keep the 1, I think.
Okay. So what is the value of the underscore?
95.
I think that's better.
It is better, yeah.
Okay. So this is 15. We need many, many more. So do you want to try 50?
128, in fact.
No, do you want to go all the way to 100? No, I'm gonna go with 50, bro. But I think I'm gonna have to do something like this. Oops.
Maybe try removing the logging and see if that helps with performance.
Oh, that's actually a good call. Thank you, Marinho. Um, so logging. So that means going here. Yeah, I think the logging is part of the problem.
That's much better.
Okay, so let's go to 128 now. Let's see a square. Well, it's not gonna be a square because of the font. Uh, it's gonna be something.
This is actually really cool.
I don't know how to judge if it's correct though, and that's a problem. Uh, how to judge if this is correct? Do you have any tips?
Yeah, I think this is actually pretty cool. I'm
No,
not
we
gonna
did
lie.
it. We like, come on, 3 hours. Not the best, but definitely it seems to be doing something. But how do we check if it is doing it?
Well, we could compare it to the Wikipedia image, like visually, by eyeball.
But that's not gonna go well, dude. Look, because the scale is different. Look at this cascading here. And also, do we know if this pattern was generated using the one in the corner?
Well, we do actually, because we know that the one propagates to the left.
I see. Yeah, but the scale, dude. Oh no, but we don't have this because this is 256 by 256, right?
Right.
So
We only
actually,
have half of that,
we need no,
actually.
not only half. We have a quarter. So we need to.
Yeah, half in 2 dimensions, so a quarter. You are correct.
Okay, do you want to call this victory though? Like, oops.
Oh, we need to fix the mod, I think. Did we fix that?
The mod is already working automatically, friend.
No, we need to fix it to be mod universe. Oh, right, it uses the universe size. That's right.
Yeah. Should we call it? Does
Yeah,
it?
I think we should. This looks kind of right. Ideally, we should try it with a square.
A
Here's an
square?
idea.
No, but this is a
What if you
square.
no, but what if you copy that output into a buffer on Emacs? Then you change the phones for a single buffer.
Not that I'm aware. Can you?
No. Hmm.
Okay, so we don't know if this is correct, but it does something, which is like cool. And I think I found it. Do you see these here? Let me zoom in.
Yeah.
So these, so it's a big and then a 3 and a 2. Here's the big and the 3 and the 2.
Yeah, what if instead of trying to mess around with the font, what if you took that image on the right and you squished it, like make it half as wide
It doesn't matter. Oh, you mean in Photoshop?
in GIMP or Photoshop or whatever you have handy?
I don't have anything handy. Hello, Nata. We won. This is the trophy. 3 hours, and it seems to work. We are trying to check if this is this though. We're trying to check if this is this. Turing complete. Damn. And in our assembly, so this is how many lines? So almost 200 lines with spacing.
No comments though,
No
because we don't
comments.
have syntax for comments.
Yeah. I mean, how do we verify if this is the correct one? God fucking damn it. Uh, so check. Imagine that somebody made a site just for this. How do you check this nonsense? Simulate. How to check the nonsense? 113 characters. We can compare this implementation. No, there are many, many implementations. Oh, wait! There are many, many
What if
implementations. That's it.
uh
We can run this and then swap the characters to be our characters and then put them in a buffer. Uh,
Here,
and
I have another idea by the way. What
go.
if we replace the underscore with a space?
Even better. So give me the ASCII, please.
Okay. It's 32. And the one, if you want to replace that with an X, just to be consistent with Stack Overflow, however much that's worth, that's 120.
In caps.
No, lowercase,
I want in caps.
in caps. Okay, uppercase, 88. And then you have to, yeah, replace that.
Oh, that's so much better. Okay. Uh, okay, do you have Python in your computer?
I do actually,
Okay,
despite the
so
fact that I dislike it.
run this now.
Can you send me the link for that page?
Yes. Why does that take so long? Because that is doing like how to put into words. That is doing many. No, we know the number, right? 40,000 primitives, right? Or something
Yes,
crazy
and
like
the
that.
syscall primitive in particular is kind of inefficient because it copies the string that it prints like a couple times.
Yeah, but it's like 40,000 primitives. I can't believe there was
Python.
no bug. Amazing. Like, we didn't have a bug in the logic. That's unexpected. What is the C code for the right primitive? This. This is the syscall actually. I answered your question wrong. This is the right syscall in C. Damn. Yeah. So
Yeah, the problem is that it's doing several copies, which is not
no
ideal.
buffering. No buffering at all.
Yeah, no buffering either.
No buffering. But it works. It totally
Ah,
works. Well, it seems that it works.
okay.
Okay, so did you run 128 by 128 with spaces and X's?
Uh, the Python implementation that's in there is actually in
True?
Python 2 apparently.
Don't you have Python 2? That might
Oh,
be the
there's
main
there's
thing.
oh there's an implementation in Python 3. Okay.
Okay, I'm gonna see if Discord allows me to send this to you. Oh, actually, I can make a file. Uh, so this is gonna be rule 110 text. Okay. Let me do
Oh,
this.
the implementation in Python 3 is flipped.
Okay, but that should be very easy to fix though. It should at least. And we can flip it in here if it's a pain in the butt.
You
Uh,
know, the problem is that the implementations here are like old Golf implementations.
they are old.
No, they are code golfing. Like they are trying to make them as short as possible, which is kind of annoying to edit.
No. But let me help you. Which case is the Python one? Which comment here?
Uh, Python 3 126 bytes as a function.
126. Oh, here. Yeah, this is the place. So instead of an O, you're gonna probably put an X. Okay, so screw it. So Python 3. Yeah, I know. I understood what you said because probably the guy is doing these shifts here, assuming that it is based on the O and the space, I guess.
Yeah, but the problem is that it's printing it backwards, it's propagating to the right instead of the left.
But isn't that a matter of just putting the one in the beginning of the top left? Marinho?
I'm that, and then if I say X space as you suggest, and then run it again, and it's completely messed up.
No, but go back to the original version. You said that it is backwards, so it starts from the top left, I assume.
Yeah, it starts from the top left.
But isn't that a case of going to hours and just putting the 1 on the beginning instead of at the end? The X.
No, because if you do that, it's going to propagate across the. It's going to loop around, basically. Effectively, you would just be
Ah.
shifting the pattern one space to the right, which is going to wrap around. So,
Yeah, no, I see. That's because of the wraparound. So we need somebody that is doing in our way, because our way will always be this way because of the wraparound. I see. Well, there are other Python implementations here.
there's a Lua implementation. Let me try that one actually.
Sure. People trying to remove bytes from it. Internet. Why? I would just want to see if it's correct. God freaking damn it. I'm gonna send it in the Chime chat anyway. So this is the output, okay?
Okay.
So it should, yeah, it is in here. I can't believe we did it in like with again no problem in the core of the logic. I'm impressed. I'm very impressed. Ah, GG boys. I'm very certain it is or correct or like surprisingly close to being correct. I'm actually gonna make a commit. One file. That's the commit. One file.
Can't we compare it to the output of the Ruby example?
What do you mean? We can compare it with anything. What should I do?
No, no, no. But if you go to Stack Overflow, the very first answer, it has a copy of the output, though it's missing the first line.
But this is not 128.
No, it's not. But if this matches the beginning of the pattern, it should match the rest because what matters is that the pattern is correct, right?
I guess it's a good enough approximation. So could you do me a favor? Uh, can you count
Yes. What you
how?
should do, yeah. What we should do is say,
Actually, I can count this.
uh,
So count characters. There, there. So he did 40. We can do 40. Uh,
actually, that's kind of not a good idea because we're relying on the fact that we are using powers of two
no,
to
but
make
we can then
the.
30. We can do 32. Doesn't matter.
Okay, that works. That works.
Okay, let me save this somewhere because I don't want to lose it. There. So, okay, so how to do that? Uh, I don't know. Oops. Oops. Oh, Emacs is showing me actually. So 38. 1, 2, 3, 4, 5, 6. This is 33. So this
Don't forget to change the universe size.
this is 31, but we are missing the one that I was there. And then 32 here. What in the balls?
Oh, that's
What?
because we're doing like
Oh,
that's because we're doing like over
128
100.
generations. Yeah. Okay. Okay. So then we grab the missing that. Actually, I'm gonna send to you, and you check if the files are equal. Okay.
Okay.
So this, I'm gonna send you in the private, because I already have stuff in the other chat that I'm saving. So this is ours. Oh, I think it broke. Okay, let me give you a file. Rule 10032 text. Sure. So here's your file. And don't forget to remove the top and remove the, because the guy is doing 40, right?
Yeah, he's doing 40.
Yeah, so let's not do that. Remove the some of the of his stuff. So rule, yeah, this is the file. There you go.
Uh,
Let me put back 128. It's so cool to watch though. Gotta say. I think I'm gonna put 64 because 128 doesn't fit in my thing.
it matches. It
It
actually
matches.
matches. It does.
Okay, so we're good.
We are good.
I can't believe it. My Geta thought we couldn't make it. My Geta thought we couldn't make it.
Oh, he underestimates my power. And yours as well.
And it's wrong. Why are you wrong? Why are you mad, sir? Oh, this is 96 for some random reason. Oh, I need to remove a little bit more. That's why. So 37. I need to have 64. And this is 59. So 60, 1, 2, 3, 4. Yep. So I'm gonna finish the
Add
stream.
a, add a few more generations just so we can see the pattern messing itself up after it fills up and loops around. Because I think that might be interesting. Maybe.
Okay, I'm,
Possibly.
I'm gonna put 128 with 64 of size, okay?
Okay. That is actually okay.
I want to see at which point it can fit in my monitor, the 64 one. Still not. Still not. There we go.
That's actually pretty neat.
Okay,
Not gonna lie.
so this is the end. Chime should reach its milestone, and I'm gonna finish the stream.